It was 1976. At long last, the human species was finally on its way to Mars with 2 unmanned Viking spacecraft. The official goal of the eventual soft landing and of the scientific objectives to be carried out was the search for life on Mars. But the Viking mission, which was to resolve those fatal questions, is there life on Mars, has inspired only rancor and continued controversy to this very day.
In this high-resolution photo taken in 1998, the face was again imaged as we see up in this corner. When that image was released to the media on April 5th, 1998, this is the image that the Jet Propulsion Laboratory, JPL, released. Anyone would agree, is a very natural-looking object. It does look like a pile of rocks and make the face look like an accident. The trouble is that it doesn't look anything like the previous image, and there's an even bigger problem for the scientists. It doesn't look like the data that came down from the spacecraft either, and that's a more serious problem, the data that this image was based on. Well, on the JPL website that is cited in the press kit, you can go there and you can see this image and the actual image that it was based on, side by side, and the recipe for how JPL got from one to the other. They put the actual image through a high-pass filter, then through a low-pass filter, then they averaged the two to get this image. They claimed the justification was to remove striping from the original image that was an artifact of the CCD chip. That's not a scientifically legitimate way to remove striping because it removes all the detail in an image. For example, from Adobe Photoshop, we see this description of what a high-pass filter does to an image. Emphasizes edge details. The important thing is suppresses the rest of the image. The filter removes low-frequency detail in an image. It's used for extracting line art and large black and white areas from scanned images.
It has been claimed that the layout of the 3 major pyramids on the Giza Plateau, including the Great Pyramid, are set on the ground to mimic the 3 stars in Orion's belt.
It's one of my favorite connections between events on Earth and events in the sky.
This is an overview of the region of Mars called Cydonia. It's drawn a lot of attention. It's just an area about 15 or 20 miles on the side, relatively small section of the whole planet, the size of a major metropolitan city these days. But its most famous feature is the one up here, which is the so-called face on Mars. And many of the other features, in fact, to some extent all of them, are anomalous in some ways and unique. Names have been given to these features. I'm not going to show very many of them in high resolution. This is the famous fortress feature. This little group of pyramidal-like objects with mounds is called the city complex. There's a feature just off the screen down here called the D&M pyramid, and so on.
This is the area of Cydonia on Mars. There's the Mars face, the 5-sided pyramid, and the grouping of ruins which we call a cluster that we believe matches the Pleiades stars. Now what I've done here is I've taken a transparency simply by going over all the detail on this photograph and marking circles over all the anomalies, even the small ones, the Mars face, This area here, you'll see those little bits and pieces. Just have a relook at it again. That is what the transparency looks like. We have the Mars face targeted. That's the most important part. The other detail here we're going to see on the star map what is special about that position. So let's take this transparency, which you know is an exact match with Mars. We're going to look at the area of Taurus, and to find the Pleiades in the night sky, you go to Orion and follow the 3 belt stars through Taurus, and you find the Pleiades. It's a common astronomical little trick that the ancients knew very well about, and they've shown Orion also finding the way through to something special in Taurus. Let's zoom in now on the Pleiades. Here's our transparency now. We put the transparency over it, and you'll see why this theory is so exciting. It's actually an amazing duplicate of the stars. I don't know if the camera can pick it up clearly, but here is our Mars face area. Can I tilt it? Is it all right? It's all right. Okay. All these stars fit by magnitude with basically the size of the anomalies. Even some of the other stars in contention here have anomalies matching. There's a grouping down here that seems to match that other grouping on Mars. But more importantly, let's see what star comes into the position of the target. Now we know that that target is directly in place, so take the transparency away. We'll now zoom in this area. So let's look at the target area. Under magnification, I'm going to lock in on this star and run back in time. Now we need to find what star is in this area as we go back into time. I'm going to run back in hundreds of years per second, starting now. Watch the small star. There it goes. Running back now, 1,000 years ago. That's 0 BC. Now we're going back to 3,000 years ago. It's over here. 4,000 years ago. 5,000 years ago. So it's 4, 5, 6,000 years ago. It's in that position. It's moved from there in the exact direction that we're anticipating. What's so important about this little star? This is our sun-like star that we're looking at, and it's 16 light years away, 15.74 to be exact. And this amount of time needed to get to exactly being in position is 17,000 years ago. In 17,000 years, it gets exactly into that position. That matches the Mars face. That is our conclusion. 17,000 years ago, that area on Mars was very, very important, and it seems to revere a sun-like star being a place of the gods, a place of humans colonizing this place on Mars. And this is more than likely in reverence of the colonization from that star. That's it.